Hey guys, so today we have day 2 of line of best fit, scatter plots, and in the calculator doing linear regression. All right, so the first slide we have, let's get rid of this. Okay, so the warm up, what did you notice? What did you wonder? All right, so on this left side, we have a scatter plot. That means it is not exactly in a shape of a function that we've learned, right? And the ones we're going to talk about here are linear, right? So it's not a straight linear. Their dots are not all exactly in a row. They're a little scattered, right? Now here we have a year of manufacturing cars and the average miles per gallon that car gets. So if I make a car in 2000 versus 2015, it looks like as I get more recent makes of cars, then the likelihood of me getting a better gas mileage, pretty good. But it's not exact. It's not like the hours I drive and the amount of gas I use. If I drive more hours, I'm going to use more gas. It is the same car, so whatever miles per gallon that particular car gets, then the more you drive, right, the more gas you're going to use. That is in a linear function. It's not like, okay, maybe if I drive 1 hour, I'll use 5 gallons of gas, and if I drive another hour, I'll use 15 gallons of gas, right? So it's much more proportional. All right, hopefully you noticed some other things there too. But for exercise 2, they're asking you to look at said scatter plot and then match it with an equation. Now, let's just do our own equation first, right? So I know if I were to draw a line of best fit, right? And we know that that's not as accurate as a linear regression line because that uses a calculator. Pretty close, right? So let me just write out in slope-intercept form what this line that I drew could be. All right, so if 0 is here, go down 1, 2, 3, 4. So my y-intercept is about -4. Okay. Now, I know that the slope is positive, right? So that's a positive slope. Let's see, why did that go away? Okay. Oh, good. Okay. So it's a positive slope, and it looks like it goes up about like 1, 2, and it goes over like 1, 2, like almost 3, right? And I see the numbers 2 and 3 here, so that is giving me a little hint. So it looks like it goes up about 2 and over more than 2, right? So let's look at these in standard form and get it into slope-intercept form because that's just easier to see. So I'm going to try B first because I think that's what it is, but you can try others. So I have 2x minus 3y equals 12. And the first thing I'm going to do is I'm going to subtract 2x on both sides. Okay. So now this cancels out. And I'm going to save a little time. I'm just going to divide everything by -3 because I've got -3y here. So I'm going to divide the 12 by -3. And I'm going to divide the -2x by -3. So everything gets divided by -3. So -3 divided by -3 gives me a positive 1y. And -2 divided by -3, negative divided by negative gives me a positive 2/3. X. And positive 12 divided by a negative 3 gives me a negative 4. And now I can see, wow, that matches with my estimate, with what I thought it would be. So the answer is B. Now, I would encourage you guys to try A, see why doesn't that work? What about A makes it wrong? And you'll see it if you put it into slope-intercept form. All right, so I'm going to clear that. Feel free to pause, copy, if that's what you need to do. Okay, and so now let's get out of here and go to the next one. Okay, oops. All right, so now we are in exercise 3, and this is talking about the enrollment at a preschool from 1980 to 2000. So it's good to know just what we're talking about. And enrollment means the number of people that go there, right? So if we have more people to apply to Energy Tech next year, our enrollment goes up. And if we have less people coming to Energy Tech next year, enrollment goes down, just the number of people. Okay, so here is my X values. Here is my Y values. And we could make a scatter plot, just like we did on the last one where scatter plot was given, and then kind of estimate a line of best fit. But here we're going to go straight to, well, what is the exact line of best fit? And again, you do need your calculator. If you have iPad or iPad or iPhone, please go to the app section and type in graphing calculator, and it should come up, but graphing calculator X84. All right. If you have another type of phone, I believe it's Samsung, go to the apps and type in Wabbit. So that's spelled like rabbit, hop, hop, with a W instead of an R. And Google it. So Texas Instruments, they do have a free one. That's how I got this. But keep trying. And if you don't have a graphing calculator, reach out to us sooner than later because there is access online. Okay, so I am going to go to Stat, and all the directions are on your worksheet. Let's see if I can make this smaller so you can see the data and this. That would be nice. Okay, so we have Stat. I'm going to go to Edit. And see how I have numbers in there already? So I'm just going to go up, and I'm going to press Clear, Enter, and do the same for List 2. So List 1 is where I put my X values. So in this case, I would have 1980, 1985, 1990, 1995, and 2000. So there's my X's. Hopefully I put that in right. It's looking a little small here. And for the Y's, 14, 20, 22, 28, 37. Okay. Now I'm going to make this a little bit bigger so we can really see what we're doing. All right. Okay, so I put the years for X and the number of enrollment. So it's a really tiny, maybe it's like preschool or daycare kind of thing for 14 kids, 20 kids, 22 kids. Okay, so now go back to Stat, and now we're going to calculate. So remember, this is bivariate data. I've got X's and Y's, so 2 sets of data. And I want to know the linear regression. What is the best line of fit? Okay, enter, enter, enter. Awesome. So now my linear regression here, and let me Let me make this smaller again. Okay, so here they have x and y. So I don't need to change those to like f of x or anything like that. All right, so now I'm just going to write out my linear regression. Y equals, and instead of a, I'm going to replace it with 1.08. 0.08 x. And instead of b, I'm going to replace it with a minus because there's a negative there. So minus 2125. And again, remember that this equation, this linear regression model, will give you a trend. So if you put in any year, if you put in like 2015, you should get a trend that the numbers are kind of going up, but the actual number of kids that enrolled in that preschool might be a couple up, a couple down, right? So it's not going to be a perfect dot on that line, but it will predict about how many people will enroll. And this is the best prediction that we have based off of our data. Okay. So again, calculator is a number one priority. You're going to need it for the test that we take on stats. Reach out to us now if you're having trouble. Okay. So that is it. Again, if you are having questions, comments, or concerns, please talk to each other, Google it, reach out to us, come to office hours. So you have a lot of options. Okay. So I'm going to give you about 10 seconds to fill out the last exit ticket on here. 10, 6, 4, 2, 1. Bye, guys.